Good morning again, guys. So let us continue with the next point. I think yesterday we talked about maybe Flask, and you might have got a chance to look at that. You might have practiced it. I hope I mentioned what is a REST web service, what exactly you can do with it, how exactly you can create a simple website using Flask. You can also create a kind of something like a REST web services for sending a JSON data to mobile or desktop applications. So this is what we have done yesterday. Okay. So now hopefully we have to look at all of these points which I mentioned yesterday. I'm going to reorder them in a little bit different fashion. So we'll start with matplotlib. It's very simple. That's the simplest part we can start with. Then we can create a couple of charts and other things. Then we'll dive into OpenCV. We'll see OpenCV basics. We'll see what exactly do you mean by OpenCV or image processing in Python is. We'll try to process images in a couple of different fashion. Everything cannot be covered in a couple of hours. So we'll try to stick with the introductory level. Those who are interested, maybe you can join another session for OpenCV details. So this is a kind of introduction to it. Then I think it's better we can put this towards the end of it, because unless we know PVM architecture, there is no point talking about the thread. So this is how we can a little bit arrange it. So this is how we are going to see all those remaining topics. Okay. So probably we'll start with matplotlib and OpenCV. I don't think we'll be able to finish anything other than this today. So remaining 4 points like web scraping with Selenium and beautiful soup. This is something which we are going to explore tomorrow. Beautiful soup, NLTK, PVM architecture, and thread. This is something we are going to finish by tomorrow. Okay. So as I mentioned, tomorrow we're going to have one more session, and there we'll finish all those remaining points. Okay. Now let us not waste more time. Let us start with that matplotlib and see how matplotlib can be used and how we can start drawing the different type of charts. Now, visualization, this is generally called as a visualization, and visualization is an important aspect of data analysis. Now, when I say data analysis, probably you might understand analysis means simply understanding the structure of the data, what data is, what type of data we are having it, what is the relationship between the different columns or different tables or different collections. So this is kind of important for you to understand so that you can start running different algorithms in it. Majority of the times, this analysis is the first step, or rather it is the required step for machine learning. So before you start with machine learning, any of the algorithms to start processing the data, mandatory for use, mandatory to start with something called a data analysis. And one of the processes or one of the stages in data analysis is a data visualization. So simply sending a data or simply having a data in place will not give you enough idea about it. And that's the reason if you try to put that in a different charts or different graphs, then it will give you more idea about it. That's why the matplotlib is kind of preferred here. Okay. So let us start with loading that matplotlib and start creating different type of charts. Now, the good thing about matplotlib is the default website. If you just go back to the default website of it, this is the one, matplotlib.org. If you go back here, they have given a very nice example section. So if you just go to the example section, they already have talked about many different type of charts, and you see how many charts are possible and how many different possibilities are there. So every single graph, every single chart is having a nice example. For example, maybe I want to start with a stack bar chart. What should I do? So the example is already given. If you want to give it a try, just copy this and give it a try and see if it works for you. So it is that simple. So what I'm saying here is matplotlib is very simple to use. All we are going to say here is go to example sections, try to study what exactly the graph is all about and how we can draw the graph. So probably this is the simplest version. Anyways, we are going to refer this a couple of examples later, but to start with, let me go back here and install matplotlib. I hope it's already installed on your machine. If not, you know how to install it now. So probably I can go to my terminal. I can say sudo. Windows does not require sudo. So other than Windows, you can say pip3 install matplotlib. Again, password. On my machine, it's already installed, so I don't have to install it again. If not installed on your machine, please give it a try. So install it. I'm going to put that on your chat, so it will be easy for you to copy and paste it and give it a try. Again, Windows people do not use sudo. If pip3 is not installed, use pip. So it doesn't matter whether it's a pip or pip3, ultimately you should have that package installed on your machine. That's it. Now, if you have it installed, let us start using that matplotlib and see what can we do with it. So to do this, to draw a chart, probably we'll have to start importing that package as usual. So like what we have imported last time, maybe something like Flask we have imported last time, or NumPy we have imported, Pandas we have imported. On the similar fashion, we are going to import matplotlib. But matplotlib is a kind of a huge library. It has many different type of language support. It has many different type of graph supports, and it becomes a little bit difficult to deal with the matplotlib directly. And that's the reason maybe you can say import matplotlib, or from matplotlib you can import something like a matplotlib.py. There are a couple of different ways you can do it. So you may say import matplotlib, or you can load a specific part from the matplotlib itself. I'll show you this way first. Import matplotlib.pyplot. So this is generally the one we are going to use. Hopefully you can understand matplotlib is nothing but the main package, and under that there is a sub package called as a pyplot. So maybe you can directly use it, but again it has to be like matplotlib.pyplot all the time. So I'm going to give it an alias, say plt. Most of the times you will see that matplotlib applications generally start importing the matplotlib like this. There is another way. You can say from matplotlib import pyplot as plt as well, whatever way suits you. So I'm going to use this one. Anyways, so I got that matplotlib opened or maybe imported here. Now what? Now once the matplotlib is imported, you will start using it for visualization purpose. And when I say visualization purpose, that means I want to draw a couple of different graphs from this section. Maybe I want to draw a simplest line chart, something like this, not even this one. Maybe a scatter chart, maybe a line chart. Maybe there are different options available here. So we'll dive into it and we'll see a couple of them. So to start with, let me start with a function, say function 1. And to start with, I need some data. Because ultimately, without data, you can't do anything. So I'm going to say that there is a data. Maybe I have, let's say, a few employees data. So employees data is split into two parts. One, employee ages, and second, employee's age, and second, every employee's salary. So basically, I want to see what is the distribution of my employees, like what is the age of an employee and what is the salary of an employee. So based on that, I can decide how senior the person is, or should I increase the salary, or should I lower down the salary, and so on and so forth. So probably for me, there are a couple of different employees. Let's say employee age is 25, let's say 30, let's say 23, 22, 27, 26, maybe 28, and so on and so forth. So probably we have got some data. I think it's better we can just put that in a better fashion, something like this. So it will be easy for me to put that in a kind of maybe a kind of zigzag fashion like this. It's okay. It depends on you actually. It doesn't matter. So we have like data 1, 2, 3, 4, 5, 6, 7, and let's add a couple of more and let's make it 10. So 28, let's say 20, 29, and let's say 31. Fine. So we have some data from 22 to 31. Fine. Now I want to put the data, the salary data for all those 10 employees. Maybe I'll start with say 50,000. Maybe the person who is having age 23 is having a salary of 50,000. That's what I'm trying to say here. Maybe 22 is little bit lesser. Let's say 45. Let's say 25 is almost like 55 or 60, whatever. 30 is almost like 65, for example. 27, maybe this is an exceptional person, so probably he has got 50 package, whatever. So 26 is maybe 30,000, whatever. 28 is not so good, so maybe he's getting 35. 29, he's getting almost like 60 or 70, for example. And 31, maybe he is kind of a senior person, so he's getting almost like 90,000, whatever. So make sure that we are having both arrays or both lists of equal size. That's important because unless we have them in equal size, we will not be able to put them in a simple chart. Okay, so basically we have got two arrays here or two lists here. Could be a NumPy array or could be a list here, doesn't matter. So probably we have some collection of data. So this collection of data, I want to use it for plotting it in a simple line fashion. So how do we do that? Now, generally, when you talk about a line chart or when you talk about the chart or graph in general, you know that there are two axes. One is a x-axis, which is horizontal. The one is on the left-hand side. Generally, we'll call it as a vertical y-axis. So what I want to do here is I want to use the ages on the x-axis and salary on the y-axis. And as the age increases, I want to see like whether the person's salary is also increasing or not. So that's what I want to check here. So how do I do this? To do this, I'm going to say plt.plot. Plot is the way we can use, or maybe we can draw something called as a scatter chart. It's also called as a scatter plot, or it's also called as a scatter chart. Scatter, actually, it's kind of a line chart, not scatter chart. It's a line chart. Scatter is having a different meaning. This is generally called as a line chart. Line chart means all the points will be connected to each other by using line. So let's see how does it look like. Now, when you talk about the plot will accept maybe those collections or those lists or arrays. You decide which one you want to go for. So we already have created lists. You can go for a list or you can go for a NumPy array as well. It doesn't matter. So what I'm saying here is, let's go for ages. The first one is the x-axis and the second one is the y-axis. As simple as that. Now, when you say plt.plot, let me call that function first and see whether it shows anything to me or not. So when I say run, it executes the program, but it doesn't display any output. Now, maybe on Windows or on Linux, I'm not sure. I mean, Linux, I know it doesn't work, but Windows, I'm not sure. Might be Windows is okay with plt.plot and it might show you a simple chart as well. But most of the times, like Linux and Mac, they do not display the graph just by saying plt.plot. They want to use a kind of, something like plt.show. So plt.show is the function that will display the graph. I think it's a single. I should have gone for salaries because we are having multiple employee salary. So plt.plot will generate the line chart and plt.show will display the chart on screen. So maybe I'll say display the line chart. Let us see what it does. So probably if I go back and say run, oh, look at that. It doesn't look good because my data is not so obvious or it's not so good at this moment. But still, I can see that the line chart is kind of going from here to here, here to here, here to here, and so on and so forth. That's the reason I wanted to go from maybe a kind of a sorted order. Let's do it in this order right now. So maybe I'll say this one here, 26, 27, probably 28, 29, and 30, and 31. So we need let's say 10. And now if I just go back, I'm sorry, we have to first finish that graph. Where is that graph? Here it is. So probably I'll have to say run, and this time I'll get a nice chart. And most of the times you will have the data in a sorted order like this, in X sorted order like this. And then probably you can see 22 age person is getting almost like 50,000. Maybe 23 ages person is getting almost like 45,000. Maybe 24 age person is getting somewhere near. We can predict that right here. It might be getting this one. So 25 age person is getting this much, and so on and so forth. So basically what I'm trying to say here is like, this is the way we can generate a graph. And you see how simple is that? There is nothing difficult. There is nothing maybe outstanding here, or it's not out of the world. It's just simply taking two arrays or two collections, one for the x-axis, the other one for the y-axis. And whatever the values here are, they will be mapped with the values we are here in the y. So that's the simplest way. I hope you are also able to see the graph or chart on your machine. Are you able to see that now? If you want to exit it, don't close it. Just say Q for quit. So if you open that graph and say Q, it will automatically quit. Good. So many of you are saying, yes, it's working for you. That's great. So if you can see that, it's very good. Let's see and add a few more details. Right now the graph is shown, but I'm clueless. Like, what are we getting here and what are we getting here? Of course, in Windows, it's not working. What could be the reason? Shrikant, what is an error you are getting? Okay, so I was saying like there is no clue about what type of data are we showing. So I don't know what these numbers representing, what these number representing. So what I'm going to do here is I'll start step by step fashion. So this is my function one, fine. I started with a simple graph. In function two, I want to add a few more details into it. So let's come back here and say function two. Yes, Shikan, are you using that plt.show? Hopefully, if you're copy pasting the code, then it should be there and it should work for you. Okay, so in my function two, what I'm going to do here is I'm going to add a few more details. Now, when I say details, Right now, there is no detail. I don't understand what exactly that graph is all about. So let us say PLT dot X label. X label means on the x-axis, I want to say what exactly those numbers representing. Those numbers are representing salaries in thousand. So whatever we can say. And on y-axis, okay, Sangram, it's working for you on Windows. So Shrikant, there is something problem from your side there. On y-axis, y label, I want to say that, I'm sorry, it's my bad. It should be the y-axis and it should be the age axis, right? So maybe I'll say employee age, and this is employee salary. Maybe I'll say employee salary, sorry, employee salary in thousand. So this is what I'm representing on the y-axis, okay? Next, I want to also add a kind of a title. So title is nothing but the one which will be displayed on the top. What are we trying to show here? I'm trying to show age versus salary. So basically how the age is changing and how the salary is either changing or decreasing. So reducing, whatever. So that pattern I'm trying to show here, and probably, that looks wonderful. So can you see that? We are having age versus salary as a title. We are having employee salary in thousand on the Y label or on the Y axis, employee age on the X axis. So now at least looking at this, anyone can understand what is going on. So what is it? It seems like we are having the salaries on the Y axis and age on the X axis, and we are trying to show a chart of age versus salary. So now anyone can understand what exactly is going on, and that looks wonderful. Now, when you are talking about something like maybe age and a salary, probably I want to go further and add a few more things into it. So, of course, salary is nothing but the income, isn't it? But it's not only the income we have the turn of expenses as well. So probably what I want to display here is like expenses as well. So along with the salaries, a person having maybe the salary X should have a Y expense as well, right? So let us see what exactly it is. Like in DSP practical, we have done this. Very good. That's great. So probably when you talk about a person having age 22, maybe he's going to have some less expenses because he's the one who has just started the career. So probably expense size, he is just having say 10, maybe, yeah, exactly. So let's say 10,000, for example. 23, maybe expenses are a little bit increased. Let's say 15,000. Maybe a person having 25 age is having, let's say, expense of 20,000. Maybe at 26, maybe this is having a 26, 22,000 as a kind of expense. So this is 26, 27, maybe I can increase it to 25,000. Maybe 28, at the age of 28, maybe the person must have got married and other things. So, expense must have got increased. At the age of 30, he must have bought some, or he must have some house and cars and other things. So must have the EMIs and other things. So 35,000. And the age of 31, maybe I'll say around, let's say 36 or 39,000, whatever. So these are expenses I'm talking about. So when you say that I have ages, I have salaries, and I have expenses, I want to display a kind of graph which will show me like at the age of X, what is the income and what is an expense. That will give me a kind of a good idea about how people are getting the income and how they are spending that money. So probably what I'm going to do here is I'm going to go back and add one more plot. This plot is again going to be ages will be on x-axis, and on the y-axis I want to put the expenses. So this is what I want to go back and put the information here. So now if you pay attention, a little bit closer attention. So here I'm not going to have one, but I'm going to have two of them. So one will be age versus salaries, and the second one is age versus expenses. I want to superimpose both of them. Now, when I say superimpose, let's see how many values are here. 2, 2, 2, 2, 2. I think we are missing one. Am I right? We are missing 2. 2 plus 2, 4 plus 4, 8. We are missing 2. Okay. So maybe I'll say 39 and let's say 40, whatever. So let us see what happens now. So probably we are having a function 3 here. And if we're having function 3, there we are having 2 lines instead of having 1 line. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 2 plus 2 plus 2 plus 2 plus 1. Okay, so I think we are having only 9. Okay, so not a big deal. And you see that now we are having two lines here. One line is representing the salary and the other one is representing a kind of expense. Haha, can you see that? As the age increases, the salary also increases. See, I got a pattern here. So looking at data visualization, anyone can understand the meaning of it. Maybe numbers look boring because number might not give you a kind of impact or kind of pattern just by looking at them. But looking at the graph, anyone can say that, hey, as the age increases, the expense also increases. And that's true. In the real life also, you might have seen that. So probably, I think that looks wonderful. I mean, not that wonderful, but at least to start with it, I think that looks okay. And probably what I want to do here is I want to add a few more details into it, because again, I'm not able to understand what those two lines represented. I mean, is it a kind of a line which is representing a salary, or is that orange color line is representing a kind of, let's say, an expense? So I'm not I'm not getting what exactly it is. So what I'm going to do here is I'm going to come back and try to add a few more details into it. Let's add a few more details into the next function. Say this is a function 4. I'm going step by step so that you can understand what is the journey that we are having right now, or where we started and where we are going to end with this matplotlib now. So this is function 4. This is function 4 again. And right here, I'll add few colors. So probably I can add a color and say, maybe salary is kind of income. So maybe I'll put it as a green, and color is kind of expense. So I'll put it as a red. So at least it'll give me an idea, like green is nothing but the income and red is nothing but a kind of an expense. But still, it's not very clear. So what I'm going to do here is I'm going to add a label here. So probably I'll say that the label is nothing but, what are we going to display here? I think we are displaying salaries. So I'll say salaries, and I'll put a label here and say that, oh, what is it? It seems like it is expenses. I mean, expenses column. Let's see what happens here. Probably adding a label here has not done anything other than just adding those colors. So label is kind of invisible right now. It's invisible right now because we are not making use of it. So how do I use a label then? To use a label, we can go back and say, hey, it's better you can just start showing a legend. So I'll say show legend. So probably here I'll say add titles and the labels, title and labels for different access. And now I'm going to show a legend. Now, what is a legend? You might have seen that in chat. Sorry, in chat we generally show a kind of what exactly that line is representing. That is generally called as a legend, and it's very simple. All we have to say here is just call that function called as a legend, and you are done. So probably now if I say run, you might get a complete picture clear here. Okay, it seems like it is a age versus salary. Now red color representing expenses, green color representing salaries, and that's how it is. So probably looking at this might give you a complete picture clear. Not complete, but at least a better picture clear, because now I can understand what am I trying to show here. Okay, so that's the way we can simplify the data visualization or data analysis process. So probably now you can understand like how the graph can be created. Now, while creating it, probably you can also go for one more, maybe something called as a plt.tight layout. Now, tight layout is the way we can add every single thing into one single square part of it. Or maybe I can say add, or maybe display the graph or display the chart with equal spacing around the edges, around all edges, or around all borders. So it will be like the entire graph will sit in the center of it. So probably this looks better. Last time it was not looking a kind of not in the center. If I just try to resize it, it will look like in a center, and it will have a better layout. Look at the difference. When I do not have this tight layout, this is how it is. Maybe you are having a kind of extra padding here, or extra spacing here. There is no spacing on this one. There is some spacing here. There is some spacing here. So it's unequal. So if you really want to go back and put this in a better fashion, you can use that function called as tight layout. And yeah, that looks wonderful. So this is how we are creating a very, very, very simple graph. And this graph is representing a line chart. There are different options available here. Probably you can say plt.scatter for scatter chart. You can go back here and say the same thing, ages and salaries. And probably if I say run, it is now going to import, it is going to superimport or superimpose the scatter. Scatter means the dot. Dot means, you see, this is the dot, it is dot, this is dot, all of them are the dots, and those are representing the points, those points which are now connected by using plot. So this is the scatter chart, and plot chart, or maybe the plot is going to display a line chart. So probably this is a scatter or point chart. I'll do one thing. I'll use the same color, so it will be easy for me to recognize this. And I'll put one more, let's say line chart and a scatter chart. Let's group them together so we can have only two labels there. The second one is expenses, and we'll use the red color. So now at least I'll know like where it has the point and where the points are getting kind of connected by using the line. So the green color and the red color, they are now representing salaries and expenses, and we are having two different graphs superimposed on top of each other. One is the line chart. By using plot, we are using a line chart, and by using scatter, we are creating a scatter chart. So scatter chart means all the dots, and line chart means all the lines. You can also go for individual charts as well. Like if I just go for a scatter chart, this is how it will look like. Doesn't look very good. So that's the reason why we started with the line chart, and now we have superimposed the scatter chart on top of it. So I know where the point is, and I know how the points are kind of connecting together. So that's how it is. Now you can understand like how the values are kind of superimposing, and how that graph is kind of giving you a much better idea about your data. Now imagine that you want to share this graph with someone. Probably you want to use this graph maybe in your PowerPoint presentation. Maybe how do you do that then? Now to do that, you can generally start this one and you can take an external screenshot. Maybe if you're on Windows, you're having a print screen button, or if you're on Mac, then I can take a kind of a screenshot like this. Fine, I can get the screenshot, but you know, this is how the screenshot will look like. But it's not required, because when you are using something like a Matplotlib has a built-in functionality to put this graph in a file, or to save this graph as a file. So maybe I can say save the graph or save the chart as a file. And it's very simple. Again, you can say plt.savefigure, and you can just give it a path. Let me see on my, yes, on my Explorer side, I don't see anything there. So probably there is no file. Now I'm going to create one. So maybe I'll say age versus salary versus expense .png. So this is where I want to store that file. This is the image which will be kind of getting created behind the scene. And of course, I'm going to show this. That's the reason why it is able to show me the graph on screen at the same time. You see, I've got this image here now. So if you look at the image, it shows me age versus salary versus expense.png. So if I double click on that, I get exactly same image. And probably you can see it now. If I open this in my Explorer, that's called as a Finder in Mac. So here it is. And if I click on that, you see, it's very nice representation. I can put this directly in my PowerPoint presentation and I can continue with it. So that's how we can save a line chart. I mean, whatever chart you are using, it can be saved by using a function called as save figure. Save figure stands for save figure. I hope you are getting it, and it is giving you exactly same idea what you are able to see it here. Guys, is it working for you? Okay. Yes, it's very good tool for signal processing rather than having a traditional C for that. Absolutely. And see how simple is that? That's the reason why Python is the de facto standard language for IoT type of applications. I don't know how many of you are in that domain, but if you are, then probably you can agree that in IoT, Python is the language which is used. Does the file have some directory? It can be. You can say that. Maybe if I have one more directory here under this one, I'll say charts. And then if I want to move this file into the charts, all we have to say here is just go and say charts under this. I want to create a file. That's it. So probably, I can just go back here and all my files, all my charts will be collected inside a directory called as this one. Okay. How does it work behind the scene? How does it work behind the scene in a sense? It gets the data, it tries to use that maybe a kind of a chart by literally drawing those lines and dots. So behind the scene, Matplotlib literally creates a simple, or maybe you can say empty canvas. This is called as a canvas, and on top of the canvas, it tries to put the lines and it tries to put the dots. If it is a plot, it is line, and if it is a scatter, it is trying to put the dots. Okay. Vipin, even in the cricket bowling, they also say the chart. Of course, charts are everywhere. So chart is one of the ways you can represent the data. That's the reason why it is called as a data representation, data presentation, or data visualization. Couple of different names. They are trying to signify the only one thing, that you want to analyze the data in a better way. Instead of just looking at the numbers like this, you might not get anything out of it. So if you don't get anything out of it, don't worry, just put that in one graph, and then you will at least get something about it. So maybe that's the reason why data visualization is one of the important stages in machine learning as well. There is a save icon on the graph. Can we use that as well? Yeah, of course you can. So probably if you just go back here, you can go back to and save this file on your own, or you can programmatically also do that. Now, why did I show you that programmatic option? Sometimes, let's say you are you want to get this you want to get this particular file into your let's say website somewhere. So in the website, you don't want to see that, you don't want to show this to user on screen like what I was showing you here. You want to do this, or you want to generate that figure on a click of a button. So programmatically, I'm saying, how do you do that? This is the way you can do it. I'll show you one thing here. See, if I go back to this one, I'll delete this file here. And now I'm going to say run, because I am not showing the plt.show. Plt.show will not show me the graph, but you see behind the scene, it has already created that image. So if you want to do it programmatically, without showing that or without displaying the output to the user, if you just want to create an image out of it, this is the way you can do it, right? So Amrinder, this is the reason why we are going to do it. Okay. You may use that save icon, but that's the reason why I showed you that. So if you want to do it programmatically, you can do that easily. That's the reason why I wanted to show you that this demo yesterday inside the chat section, but it's okay. So we already have done that yesterday. Now we are having this separately. You just combine them together and get this image inside your chart, inside your HTML page. Shrikant, is Matplotlib calling at the background NumPy? No, I mean, it's not using a NumPy directly at this moment, but if you are having these lists replaced with NumPy, that also can work there. So it's not using NumPy directly. See, this Matplot library or Matplot package is not meant for processing your data. This has kind of a functionality to display the data. So it's not using a NumPy, but it supports NumPy. So basically, if you are having a NumPy array, you can still pass it directly to that Matplotlib. Okay. Vivek, you are getting some error, model is not found. So probably it's an installation. Check your installation and see whether it is missing something. Utpal, can we also plot a graph directly from CSV file or Excel sheet? Right now we are having the data like this. Now tomorrow, if you want to use the data from one of your CSV files, you just replace this and hopefully that will work, right? So probably if you are having that file, salary data, you can just read the file, you know how to use that from the pandas part, use the pandas data, show it here, and probably you can pass it. The rest of the things will remain as it is. What is going to change? It's just an array. Instead of using a kind of hard-coded values, you can read that data from your simple CSV file. Pandas can easily read your CSV file, get the data in a kind of a tabular fashion in data frame. Use of zeros will give you all the values, and just go back and put the values there, right? I hope, Utpal, you must have got the idea what I just mentioned here. So this data, instead of hard coding it, you can read it from CSV, you can read it from Excel sheet, you can read it from database. Doesn't matter where the data is coming from. This part is going to remain same. So that's more important. Okay. Nidhi, is it possible to save the file in some common repository or the network drive? Of course, the path will change. So if you know that there is an NFS drive shared in your machine, or maybe there is an external NAS, that's something called as a NAS, network attached storage, which is attached to your machine, you can just give the path. So here you don't have to do anything. It's just the path you have to specify here. The path has to be configured separately to share the data or to have a Git repository or whatever it is. So here you can't do anything other than just give the path. Rest of the things will be done externally. Okay. Yes. Okay. Anyway, so now you know like how to draw a simple chart. Now let me just go back here and show you one more example. I think it's better we can get that example right here itself. Maybe that's okay. So we can go for a very simple example of something like a pie chart. I mean, I love that pie chart. So I'm going to go back here, search for pie chart. pi. Here it is. So I want to go for this example. This is a very simple example, and I like it. So let's go for this particular example and see how we can draw a pie chart like this. The good thing is whatever chart we are going to draw, that chart can be saved to a file. So you can directly use this into your websites as well. Okay. So let us see how it can be done. It's very simple, by the way. So this is going to be my function phi. Right inside it, let's take an example. What should I go for? Let's say, let's take an example of a student, and let's say student is having some marks. Maybe the exams are pretty much over right now, so probably I'm going to just get marks of a student from different subjects. Okay, so probably I'm thinking like this: we are having a marks, that's another array, and we are having the subjects, that's another array. Like what we have done last time, ages versus salary. This is what I'm going to do: marks versus subjects. So let's say there are subjects like maths, there is computer subject, there is science, whichever science it is, science, and let's say language, whichever language again. And what am I missing? Let's say that's okay, more than sufficient. And let's say biology. I love that, biology. Okay, so now let's understand like how we can use this data and put that in a pie chart. Of course, to show the data in a pie chart, we have to have different marks for this subject. All of them are out of 100, for example. So this student has got, let's say 60% out of 100, for example. Computer, he's good at computers. He must have got, let's say 80 out of 100. Maybe science, he's quite a good, let's say 60 out of 100 again. Language, maybe not that good, let's say 45. And finally biology, maybe biology he's getting almost like 70. So that's it. This is the data I'm having, and I want to display this data in something called as a pie chart. Please take an example of pandemic situation, number of people affected versus recover. That's good. Shrikant, you can get the data and then you can put that here. So whatever, it depends on you actually, what data you are having. I was trying to show you a data very simple like this one. So you can say instead of ages, you can say the different areas or different states, and different states are having different thousand numbers of people who are affected due to the corona, right? So data is something that you can take, but still this code will remain same. So probably you must have got an idea. Here, instead of using ages or salaries, you can put any data. The technique will remain same, okay? Okay, so probably you can say a student's marks like this, and probably I'm going to go back and try to put the data into a simple pie chart. So how do I do this? Again, same thing, plt.py. So plt.py is where we want to put the data. Yeah. So probably I want to say that these are the data, these are the values I want to put. Maybe let's see how does it look like first. plt.show. This is my function phi. And let us see how does it look like. So if I just use the marks here, then I think it's getting shown. Probably you can see that it's having all of this information here. So probably if I add all of these marks together out of entire, I mean for a student, for the entire exam, how much he has got. I mean, I don't know which percentage is for which subject, but all of them will give me 100%. And out of that, it is calculating their percentage for different subjects. So this is how the graph is getting shown. The calculation is getting done automatically. We can't do anything for that. It's getting done automatically behind the scene. Okay. But looking at this diagram, I don't understand what is the yellow color or maybe the orange color representing, or the blue color is representing, and all of these colors are representing. So what I want to do here is I want to go back and say, hey, please tell me like which color is that, or which subject is that color representing. So this can be done by saying labels. Last time I used the label here to say that this is a salaries plot and this is a expenses plot. Similarly, here we don't have one label, but we have multiple labels. So now we can put the subjects there. So it will understand that, okay, so this is maths, this is biology, this is language, this is science, and this is computer. So automatically it has started adding some data, and based on this, probably I can understand, okay, maths. So this person seems to be very good at computer. So that's what we can understand by looking at this particular, or maybe he's weak in languages section. So that's how we can get the understanding of it, you know. So looking at a student's marks, so one student's maybe marks in different subjects, I can understand like which subject is a strong and which subject is weak. So this is the kind of understanding I can immediately get by using this particular information. So that's how we can do the job. Now, probably if you want to compare this with this graph, I think this graph is having a nice shadow in it, right? So probably I also want to display a shadow. How do I do that? Maybe I can say shadow is equals to true. That's it. So now our graph is going to have a nice shadow here. I mean, we can control the shadow position as well, but for now it's okay. This is a kind of shadow we can enable. I don't know whether you can say this, but there is one part which is kind of exploded out of this. When I say it's exploded out, it seems like we want to create one more explodes array. Explodes means the one part is kind of maybe a kind of taken out of this. So how do we do this? Which part you want to take out? You just have to add some more percentage to it. For example, I'll say 0, 0, 0, 0. All of them are 0. So I'll just go back here and say explodes. This is the property we are going to use. Explode is equals to explodes. Explodes means what percentage of this math subject or computer subject you want to explode out of this pie chart, or you want to take out of this pie chart. Right now, nothing is going to happen because I've given all explode equals to 0. Let's say I want to highlight computer. I want to take that computer out. So just come back here and say, let's say 0.1. Let's see how much it goes away. And then we can adjust the percentage then. You see, when I say 0.1, it just got kind of out of the entire pie chart. Fine. I can come back and let's say 0.3, and it will be more going out of the pie chart here. So you decide which one you want to go for and how much percentage you want to add there. So probably I think 0.1 looks okay. So that's how we can do the job. This is called as explode, and explode is the functionality with which we can take some part out of the pie chart. Yes. Sneha, you are saying how can we add a percentage to this part? I was about to say that. Thanks for reading my mind, by the way. So to do this, this is the one, auto picked. I'm just going to copy this as it is. This is the one, which is going to put the auto percentage. PCT stands for percentage, and 0.1.1 is the way we are going to have one point after decimal number. So this is how we can say that the whole mark system for that student is telling me 25% is a kind of a computer's mark. That means this person is very good at computers. This person has languages section very weak, because out of the entire marks, 14%, 14.3% is something he has scored in the languages, which means he's not good at the language. So whatever you can say. So looking at this, you can understand what exactly the information is telling you. I think we have covered 1, 2, 3. I think that's it. There is nothing other than that is required. So probably you can see a very simple example of it will show you how the entire data is added into a pie chart. Like last time, I'm going to use something like a tight layout. So maybe tight layout will give me a kind of better understanding, better percentage of spaces around the entire edges. And finally, I'm going to save this image to my chat section as well. To do this, I'm going to say plt.savefig. Again, we already have a chats directory right there. Yes, it's chats. And then I'll say py.png, or maybe subjects, or subject versus marks, or maybe whatever. I can say student marks .png. Okay, let's say run. Probably I'm getting the figure on the screen, and on top of this, I'm going to see here as well. See, I got the image as well. So this image is something which I can include in my PowerPoint presentation if I'm giving a demo of it. So that's how it can be used here. Very, very, very simple. Now, based on what we have just discussed here, you can go back to any of these examples and you can use the entire code there. So hopefully, if you know what exactly the base system is and how you can do it, probably you can start using any of these examples here. Google Form also uses this tool to show the pie chart, and rather than submitting the info, it's visible. No, Adesh, Google doesn't use it, because when you go for websites or when you go for developing a web applications, see, Python is good when you are doing it locally or when you are doing that processing here. But when you are going for website development, every technology has its own library. For example, when you are developing websites, then we generally do that in JavaScript. And in JavaScript, there is a d3.js. This is something which is equally powerful with that matplotlib when you compare it with the matplotlib. So if you just go to this library, this is also a kind of giving you various different options for charts. See, there are all options available, but this is in JavaScript. So whenever you are developing websites there, maybe using JavaScript, so we generally use this library there. Okay, so Adesh, depending on what type of application you are developing, you can choose. So if you are developing a machine learning, I would definitely go back and use matplotlib. But if I'm developing a web application, then I would rather use D3 because it has JavaScript in it, and mostly we can use JavaScript in the web development. Ketan, for Angular, you can use this D3 language, D3 library, or if you want to go for Angular, there is another one, something called as a chartist. Chartist is also a very simple way to display different charts on screen when you are developing Angular application. See, I already have given some Angular examples right here. So if you are an Angular developer, for that, I mean, for you, this is the library. There is a chartist. I mean, I like this because I use this in various different applications when I develop Angular application. So I use Angular, I mean, I use Chartist for my Angular. I use D3 for rest of them. So generally when I develop PHP applications, I use D3, and for Angular and React, I use Chartist. There are various different options available. There is a Chartist, there is a X-Chartist, sorry, X-Chart or X-Chartist. I don't use this much. I mean, there is one actually, but I don't use this much. I like Chartist option if you want to go for it. For Angular, yes. For Angular, this is the best option if you want to go for it. There is another one, NGX chart. This is a kind of a wrapper over the chart, sorry, NGX chart. So this is another one if you want to go for Angular, but I like this one, Chartist. I mean, on top of it, we can use this one as well. So depending again, which type technology you are using, everyone is having their own representation. Okay. So I think Adish, you got the point. And yes, I think Ketan and Utpal, this is the one for Angular. This is the one for PHP, and this is the one for Python. Okay, that's great. Anyways, Chat is better for React also. That's what I said. React, Vue, and Angular, all of these three, maybe you can use a Chartist because all of these three technologies or all of these frameworks are developed in JavaScript. So when I don't develop applications in Vue.js, but I do use React and Angular a lot. So in both the cases, I use Chartist. Okay, excuse me. So let us continue further and see maybe the next part. I hope you know now what exactly the matplotlib here is and how you can use it. You got a kind of basic understanding. Now, if you want to learn few more different type of charts, you can learn on your own. They already have given basic examples. Go ahead, whichever graph you want to go back, say this is the example. Now you understand what we are doing here, what kind of functionalities is getting embedded inside this particular example. We already have seen a couple of examples here, so probably that will give you a kind of understanding of this code. And again, the good thing about matplotlib is they have given ton of examples. It's just matter of copy pasting the example and see how does it work. Okay. Anyway, so this is how we can create a very simple example in matplotlib to display different type of charts. Okay. So now we are coming back to the next part. Yes, so Priyanka, not possible to go for signature processing, but the next library is going to give you enough understanding about how to process an image. So your example, or Priyanka, your requirement is how to process a signature, but I can't just simply go for a signature. I can give you a kind of understanding of how the images can be processed. Okay. So now we'll try to go for the next page, page 2.py, and there we'll start working on the next part, and that is OpenCV. Okay. So let us see what OpenCV is and how we can deal with it. Now to start with this, I need to go for an iPad. Just give me a sec. Let me copy my, so let me copy that PDF file here in my PDF. I'm sorry, in my, just give me a sec. Forgot to copy that. Otherwise, I would have directly started it. So sorry for that. Okay, so I think I created a directory for you people last time. Python. Do I have it somewhere? Leave it, not a big deal. So this is the one. I'm going to go back and put it on my iPad here. Good notes, it's here, and insert it. Okay, and let us see the basic fundamental of OpenCV first, because unless you understand that, there is no point of just going further and talk about this one. So this is the OpenCV. Just give it a sec. Yeah, it's coming. That's good. So let us understand this. Yeah, Priyanka, just give me some time. We'll come back to your point, okay? Okay, so this is OpenCV. Let us see what exactly OpenCV is. Now, by the time, as we are having this kind of understanding here about the OpenCV, by the time, let's go back here and you start installing OpenCV on your machine. So probably just search for OpenCV on Ubuntu, OpenCV on Windows, or OpenCV on Mac, and just start installing it. It will take a couple of minutes for you to get it installed. So by the time we are discussing the fundamentals of it, you will have it readily installed on your machine, and then we can start writing the code together. Okay, so let us understand what OpenCV is. Now, when you talk about the OpenCV is kind of a library which is used for processing different images. Very simple. It's a library which is used, or which is developed for, yes, it's a programming library which is developed for real-time computer vision capabilities. Now, when I say real-time vision computer vision capabilities, that means like what our eyes can see. If I want to do that programmatically, OpenCV is the library. It was launched in 1999, so old and so famous. OpenCV is from the Intel initiatives. I mean, there were a couple of companies along with the Intel. They collaborated together, and they have developed this library in 1999 by using a language C++. And from then, this is one of the de facto standard in image processing. And believe me or not, OpenCV is heavily used in deep learning. If you're going for machine learning, there's a section called as deep learning, where we have to process different images, the image recognition or image extraction or OCR. There are different functionalities which are built on top of images, and there image processing is required. So generally at that point, OpenCV is the library which is preferred there. The major version 1.0 was released in 2006, very old. Second in 2009, and third in 2015. The one which we are using right now is 3.0x, I mean 3.0 above. It has many algorithms provided for processing, to change color, to resize it, to find out, to extract some information out of it. There are many different algorithms given here. Those who were having the subject of DSP, digital signal processing, and image processing in their syllabus, probably they might recognize all of these algorithms there. It supports many languages like Python, C, C++, Java, and so on and so forth. So today, if you can understand some basic fundamentals of OpenCV in Python, I can bet on that similar code. Functionalities also will remain same. Function name, more or less, it will change as language changes. Syntax might change from language to language, but the main concept will remain same. So you can use the same concept in different languages as well. So if you're coming from Java, you can still use OpenCV in Java. If you're coming from C++ or C, that's the main language where the OpenCV is, OpenCV literally shines, because the OpenCV itself is developed in C++. And the good thing about OpenCV, that it is a free and open source, which means you don't have to pay a single penny to anyone. Use OpenCV freely, download it, and then start using it. It's very, very, very simple. We'll see that in a minute. Let us understand first what different OpenCV can do, or where the OpenCV can be used. It can be used for 2D or 3D feature toolkit. It can be used for street view image stitching. So I don't know whether you are aware about the fact that when you're opening Google Map, it shows you a street view where you can just look around on the street. If you're using iPhone, then Apple Map just started supporting the different street view, maybe in different countries rather than only US. Now it's now supported in UK and a couple of different countries in the world. So that can be done by using OpenCV. Emojicon estimation, whether the emojicon or maybe the emojis, whether that's a happy emoji or maybe a kind of sad emoji, or what kind of expressions you can have. Facial recognition, again, that can be done with OpenCV. OpenCV can be used everywhere. Gesture recognition, again, I don't know whether you are aware about the fact that there is a Microsoft gaming console called as Xbox. Xbox comes with a kind of accessories called as a Kinect. So if you have seen that Kinect, then you might recognize that next to the Kinect, I mean, if you want to play a badminton game, so you don't have to have a racket in your hand. So you just pretend as if a racket is there in your hand. Maybe you can stand in front of that Kinect, which is given by Xbox, and you can just use the gesture, and the character in your game probably will act accordingly. So that is called the gesture recognition. Very, very fantastic demo. Just go back on YouTube and you can watch that. It's called as Xbox Kinect. So that is again using OpenCV behind the scene. There are many different applications there. Human computer interaction or mobile robotics. There are many different things: motion understanding, object identification, whether it's a bicycle, whether it's a headphone, whether it's a phone, whether it's a computer. All of these objects can be identified by using OpenCV. I mean, not only OpenCV. OpenCV is the major part. Rest, it has to be done by using ML. And there are various different options available. You can take a look at it later. One of the simplest example, maybe if you are traveling from a car, then probably you stop at a toll booth, you pay your maybe taxes or whatever tool collection or tool booth collection is asking you, and they give you the receipt. So when they give you the receipt, you can look at that receipt and you can see your number there, your car's number there. What do you see? That is that person sitting on the toll booth is literally typing your car number by hand? Of course not. There is a camera. The camera takes takes an image. It extracts the number plate out of that image, and it automatically converts that image number plate into a textual information. This again can be done with OpenCV. Many various different medical image analysis or structural information from motions. There are many different things can be possible in OpenCV. OpenCV itself is a kind of a career for a few people. So OpenCV is a very famous library for image processing. Anyways, so there are many different options possible. But if you want to go back to the OpenCV, how does it work? Now, OpenCV, as I mentioned, it's a kind of a framework. It's not a single library. It's not a simple package. It's a kind of a framework which has many different things out there. So OpenCV is divided into different modules to provide the image processing capabilities. The main part is called as the core module. The core functionality of the module defining the basic data structures and also the basic functions used by all the other libraries. So here, how to load that image, how to represent that image, how to do the basic calculations of that image pixels and so on and so forth will be given by that core library. On top of it, there is the image procs. The image proc stands for image processing. So image processing module that includes the image filtering, geometrical image, transformations, color image, and whatnot. There are many different things available here. Image codecs will give you different type of codecs to read different type of images like PNG, JPG, BMP, so on and so forth. Video IO that can be used for video capturing and the video codecs. So basically, whenever you are talking about the OpenCV, OpenCV has ton of different modules, and depending on what you are looking for, you can use that module and call the functionality. For example, DNN, it's a deep network, deep learning network. Object detect, used for object detection. Feature 3D, detecting a feature out of an image. Maybe there is a photo for scanning, stitching for literally stitching different images together, shape detection, calibration, image processing, image codecs, high GU. There are many different functionalities out there. So ML, it has its own inbuilt library or inbuilt module called as an ML. So there are many different things here. OpenCV alone can give you a functionality like OCR, optical character recognition. So you might have seen that many a times you scan an image and you can get the text out of it. So that is again OCR, maybe optical character recognition, that can be also done with OpenCV. OpenCV has built-in, not all the machine learning algorithms, but few machine learning algorithms that can be used for doing the simple job like OCR. So there are many different things in OpenCV. OpenCV is a great framework. It's not a single, but it has made up of many different modules together. Now, if you want to deal with OpenCV, you need to understand what images. So basically, unless you understand what images and how it is stored on the disk, you cannot use this OpenCV. So let's understand what images, and then let's see how the image is stored on the disk, and then we'll use OpenCV to load the image and then do some kind of processing there. So when you talk about an image, what is an image or what is a photo? An image is an artifact that depicts the visual perception, such as the photograph or other two-dimensional picture that resembles the subject, usually the physical object, and thus provides a depiction of it. I mean, pretty much mouthful of it, because I know it's a very long definition and I'm damn sure you didn't get anything out of it. So in short, image is nothing but that converts your 3D world into 2D world. So basically, whenever we see, our human eye see, we can feel the depth. We can understand that's a 3D. But for image, you cannot just get a 3D out of it because it converts your 3D information into 2D. So basically, it can be seen as the two-dimensional view of a 3D world. So that's what an image is. When you take a photograph, then you generally converts your entire 3D information into two-dimensional part. This is generally called as an image. This is a digital image, which is a numeric representation of a 2D image. So basically, when you take a photograph and if you want to put that on your machine, that gets converted into a digital information. How does it do that? I'm going to explain that in a minute, but this is a kind of an image that we are going to deal with. Digital image, okay, not not the one which is there in your camera or in your phone. We have to get it on your machine, and then we'll have to do something with it by converting it into image that OpenCV can understand. That's called as a digital image. We'll see that in a second. So what exactly it is there inside your image? It is a finite set of digital values which are called as the pixels. I hope you know that whenever you are talking about an image, or whenever you're talking about a video, for example, we generally talk about a pixel, or we generally talk about the resolution. We say that I am watching a movie of a blah blah resolution. For example, when I say I'm watching, let's say a movie in a high definition, so probably I'm talking about 16.9. That's an aspect ratio which we generally use for high dimension. So probably I can say this one is 1920 by 1080. That's a full HD. Or maybe 1280 by 720. That's a half HD. Or 3180 by 2160. That is a 4K or UHD or ultra high definition, and so on and so forth. Whenever we talk about a kind of a resolution, we always use these two numbers. One is representing the width and the second one is representing the height. But what do you mean by this? This means 1920 pixels or horizontally on one line and 1080 pixels vertically on each line. And such, simple collection of such pixels will create or will constitute one image. So what is an image? Image is made up of multiple values. Those are called as the pixels, and those pixels count will give you a kind of a resolution. More the pixels, better will be the quality, high definition of that image or high definition of the movie you generally will watch. So basically, when we talk about any image or any video, this is a kind of a fundamental that every single image is made up of a pixel. Now, what is a pixel? Probably you might have heard about this. Pixel is a shortcut. Pixel stands for picture element. So the smallest part of an image is called as a element, or the pictures element, which is generally called as picture, and then element, pixel, picture element. So that's the smallest part of an image. The goal of OpenCV is to transform this 2D data into a new representation, for example, a new image, by converting its color, or maybe by changing the image representation from one to another, something like this. Or to take a decision, for example, perform a concrete task, maybe take a feature out of it, or recognize what object inside it, so on and so forth. Or a new result, like the correct classification of the image, whether it's a cat image or whether it's a dog image, or whether it's a mobile image or whether it's a tablet image, or whether it's a computer image or whether it's a laptop image. We can do that image classification. Again, one of the ML algorithms used here to do that classification, generally called the binary classification there. So this can be done by using OpenCV, and also some useful information extraction, for example, object detection. So OpenCV can be used for many different purposes by looking at the pixel information stored in that image. Let us understand how the images are getting stored and how the pixels are getting their colors. So images are getting stored by using different pixels, and every pixel is having different color channels. This is called as a color space, or it's also called as a channels. There are several different color modes, models, also known as the color spaces. Probably there is something called as a CMYK, there is something called as a RGB. There are a couple of them available there. Those who are coming from maybe a graphics category, or if you are a designer, then you know better than this. So probably when you talk about a color space, there are many different color spaces available, but most of the times we generally deal with RGB, because RGB is the most common. It represents three colors, three common colors, R, G, and B. Red, green, and blue. These three colors will represent a different part, different pixels, and those pixels will represent one single image. So these colors are mixed together to produce various different ranges of color. You see, this is red plus blue becomes green, or maybe blue plus red becomes magenta, blue plus green becomes cyan, red plus green becomes yellow. All of them will become white, and if there is no color, then it's kind of 000. That's a black. So each color is usually called as a channel. So there is a green channel, red channel, and a blue channel, which is commonly represented in an integer value starting from 0 to 255. So which means each channel will have 256 labels or 256 values. And there are three channels, which means it's a 24-bit color information. So it's like this. This is an image. Oh, why am I showing it? Let me show you, let me show you that in the next part somewhere here. So let's say this is an image. Probably this image is a very small image like this. There is a kind of a, let's say a simple tree there. And if I just try to zoom it, you will see that the image is kind of stored in this way. All of them are the pixels. So this is a pixel, this is a pixel, this is a pixel. All of them are the pixels. Pixel stands for picture element. Remember that. So every single pixel here is having three colors. You see that there is a red color, there is a green color, and there is a blue color, R, G, and B. So whenever you talk about saving your image, every image is going to get stored into number of pixels, and every pixel will have a color, and that color can be generated by using the combination, or maybe you can say by using different values of different channels. So probably it seems like this is a green. How do you create a green? So if it is a R, G, and B, I don't need a red, I don't need blue, I need a green. So probably I know that this is how we want to generate it. But when we are representing this color in RGB, we say that it's a 0, 2, 5, 5, 0. So this is how we are going to represent that color, 0, 2, 5, 5, 0. That means we are looking at 0 R, there is no red, 0 B, there is no blue. What we are getting here is only the green channel. So this is how we can get it. If I say 255, that means I'm getting all the, the highest degree or highest value of green channel. If I say something like 100 means it will be a kind of a lighter green. So as you change the values from 0 to 255, you will get lighter to darker color. So whenever you are representing the pixels, the pixel will have different colors, and those colors will be generated by using R, G, and B. So if I want to store one single pixel information, let's say there is a pixel at 0, 0 position. And if I want to say that's a white pixel. So how do I get the white value? To get the white value, there are 3 bytes. Now why 3 bytes? You can understand that now. Because 1 byte will represent a red channel, 1 byte will represent the green channel, and the 1 byte will represent the blue channel. So let me say this is the red, this is the green, and this is the blue. Okay, so let's say I want to represent a white channel. White means all of them will be high, means this is 255, this is 255, and this is 255. So if I add all of these colors with the highest intensity, I'll get the white color. This is the representation of white color. Now when you say 255, I'm talking about the 1 byte here. 1 byte is having 8 bits. So this is 8 bit, this is 8 bit, and this is the 8 bit field. Now when I say 8 bit, it's 1111, 1111, 1111, 1111, 1111, 1111. So this is how we are representing the values. This is FF, FF, and FF. So probably if you have used these colors in different programming languages, then you might recall FF, FF, FF will be a kind of a white. 0, 0, 0 means it's completely black. And you see that now there is 8 plus 8 plus 8. There are total 24-bit image or 24-bit representation, 24-bit color information we are storing here. That's what I just mentioned here. So these images will store the 24-bit color information, color depth. So every pixel is going to store 24-bit. So if you are having, let's say in this case, how many pixels do we have? 0 to 9 means it's a 10 horizontally, and 0 to 9, 10 vertically. So basically this image resolution is 10 by 10. And if this image is having a resolution of 10 by 10, probably you can imagine, let me do that calculation here. 10 by 10 means there are 100 pixels. And if there are 100 pixels and every pixel is going to store 24 bits, that means this is going to store 2400 bits. Of course, divided by 8 will give you in bytes. Divided by 1024 will give you kilobytes. So you do the calculation and you can see that this is the value that your file is going to tell you. Like the file is having a size of blah blah MB or blah blah KB. It depends on how many bits are getting stored in that particular position. Guys, are you getting this? Unless you understand that, you can't even open or you can't even write a hello world program in OpenCV. So understanding this is crucial. Every image is made up of different pixels, and every pixel is made up of 3 channels, R, G, and B. Those 3 channels will represent different colors by having the combinations of R, G, and B. That is how the images are getting stored behind the scene. So every image is stored as a binary data, that's a pixel. And OpenCV, it uses the RGB color space by default. But of course, when it stores the value or it reads the value, it reads it not as a RGB, it reads it as a BGR. That's okay. But again, the representation will stay same. There is a blue channel, there is a green channel, and there is a red channel. Each color, each pixel coordinate XY will contain the three values ranging from intensities of 0 to 255. It's 8-bit per channel, means we are having 24-bit for every single pixel. So that's how we can do it. For example, here we are having a yellow pixel. So if I want to create a yellow pixel, the red 255, green 255, and blue 0 will give me a kind of a yellow pixel. Like what I gave you an example of green. This is an example of yellow. This is an example of a white, and so on and so forth. So that's how the images are getting stored behind the scene. If you know now how the images are getting stored, this is how OpenCV will look at this. This is the blue portion of it. This is the green portion of it, and this is the R portion of it. That's what I said right now. So for us, it is RGB, but for OpenCV, it reads the information in terms of B, G, and R. Blue channel, green channel, and the red channel. Try to understand this from this diagram. So you will understand how exactly the values are getting stored. So you might know this is a one-dimensional array. The values will get stored in only one direction, in only one dimension. When you talk about a two-dimensional array, let's say 0, 0, 1, 0, 0, I'm sorry, 0, 1, 2, sorry, my bad. This is 0, 1, 2, 3, 4, 5, 6, 7. So if I want to represent this, it's like a 0, 0. If I want to represent this, this is the 0, 4. If I want to represent this, this is the 1, 7. Something like this. So whenever we are having one single value, then we can say 1, 2, 3, 4, 5, 6, and 7. So we can directly go to the 7th value. But if I want to go for this value, it is like 1, 7. If I want to go for this value, this is a 0, 4. So there are two values there. There are two index positions there. But when you talk about an image is a kind of a three-dimensional array. Look at this value here. This is the pixel I showed you last time. This pixel is going to have R channel, G channel, and the B channel. There are 3 bits, 3 bytes per image, per pixel stored here. So this is a pixel, and this pixel is storing 3 different values. Let's say this is R, 255, G, there is a 0, and B, there is a 0. Means the pixel here is a red pixel, as simple as this, something like that. For example, let's look at this pixel here. Maybe if this pixel is having, let's say R as let's say 0, green as a 0, and a blue as a 255, means this is a blue image, blue pixel. So that is how the pixel will give you the color. When the pixel will get shown on the screen, the monitor will glow that LED with this particular color there. So the color information is stored in every single pixel in this format. This is a kind of three-dimensional array. The pixel representation is the same for all type of screens. Yes, pixel is going to represent the information of the color at that particular position. Now, depending on the monitor type, you will get the different colors there. See, again, I'm not going into too much of details of it, but every monitor has some specifications. Like few monitors are having, let's say 70% of RGB space or 70% of Adobe certification, and so on and so forth. So depending on that, you will get accurate colors there. So if you want to go for more accurate colors, you will have to pay for it. So probably you might have heard about this. Again, just because you asked, and I can't stop myself. So basically, if you have heard about this, Apple has something called as X display. So this is Apple's new monitor. This is called as Apple's X display, or maybe you can say Apple display Mac. You can go for, where the hell is that? Here it is, XDR display or X display. And you can see that this is the most accurate color generating monitor here, which will cost you hardly 5 lakhs rupees. So you see the quality here, and you see the price here. So as you go for more accurate colors, because the pixels on every single position will give you as accurate color as you are looking for. So this is the way a monitor will represent the color information, or monitor will use the color information and will try to glow the LED with that particular intensity of it. See, I'll show you that practically in a minute. But whenever you are talking about one image, let's say even if I'm using this image right here, this image is having a particular pixel here. And as you see that I am zooming it out, you see that pixelation there. You see the pixelation. That means every single pixel will start getting visually separated. It's just because we are going in too much depth of it. Every single image is made up of different pixels, and every pixel shown here on the screen is going to get illuminated by using 3 sets of LEDs, R, G, and B. So depending on the color intensity, the monitor is going to glow an LED there, LED at that particular position. If it is a LED monitor, if it is a LCD, or if it is something like CRT, then they will use different strategies. Like cathode ray tube is going to use the hit gun and will try to glow the position at that particular it will try to show or illuminate that pixel at that particular position. Every monitor is having its own way to represent it. But basically, when you talk about any image, every image rather is going to store the information of every single pixel into 3 channels, R, G, and B, right? Even if the monitor cursor also changes the pixel, of course, yes, every single thing is going to get refreshed. I don't know again how much details you know about it, but if you go for, let's say, information about your monitor. For example, I have another monitor on my other screen, which is a 32-inch monitor from LG. If you look at this one, it has a refresh rate. It has a refresh rate of 60 hertz. 60 hertz means this is going to get refreshed every after some time with the speed of 60 hertz per second. Basically, what happens here is, whenever you are moving your mouse, the entire screen gets so quickly refreshed, and it is going to change the, it's going to illuminate those cursor. It is going to illuminate those LEDs. So for example, if my cursor is here, the position at this particular point will just try to give me an emulation that there is a cursor here. This is a 2D, but it feels like I'm using a 3D system here, because it seems like this window is coming on top of the previous one. It is doing it. It is adding the shadow, all of this information, just because my monitor continuously refreshes it, right? So if you are having better refresh rate, you will get the better quality of it. More the hertz, more fast with the refresh rate. Absolutely. More better refresh rate will give you the better quality, and better refresh rate will also increase the price as well, right? So there are few monitors here. Maybe I'm not going into details of it right now, but there are few monitors where we can go for 144 hertz refresh rate, which will cost you maybe 60 to 70,000. The one which I'm using, it's a low cost. I'm not looking for too much because I don't play games on this. Generally, high refresh rates are required for gaming monitors. So if you just search for a gaming monitor, so if you just go for Amazon.com, so the one, let's say, gaming monitor, for example, if you just search for this, they will give you the high rate. The one which I'm using is this one. This is the very large, it's a landscape 32-inch, because I generally work with, different images on the same screen. So I don't have to juggle between this. So that's the reason why I'm going for 34-inch, not 32, sorry, 34-inch. And this is the one which is 27-inch, but it is costing 35,000. Maybe there are more if you just go for this and just look for the refresh rate. So let's see what is the refresh rate here. It's 144 hertz. That's a gaming monitor. So as you see, the refresh rate increases. This can be used for gaming, because you know that in gaming, your character is moving so quickly that you want to get your monitor refreshed, or your monitor has to get refreshed so fast so that you can see the character was here at this moment. Now it is on the other position immediately. So as it goes from one position to another position, the monitor has to refresh, and as the monitor's refresh speed increases, you get better FPS, frames per second. Those who play game, they can understand this terminology, FPS. I mean, once upon a time, I was also playing a game too much, but nowadays we don't find time. That's the reason I don't play game. But anyways, if I want to play a game, I have the other system there. I use PlayStation, not Xbox. So I have a PlayStation Pro and I play game there sometimes when I get time. But more than that, I hope you can understand now, whenever you are having any image, every image rather is going to store the information about a pixel by using those 3 numbers, R, G, and B. Okay, so now hopefully you can understand how the images are getting stored. Let us understand how the images are represented in OpenCV. So images are getting stored by using the intensity level of R, G, and B. But when they get read into OpenCV, as I mentioned, OpenCV does not use RGB. OpenCV uses B, G, and R. So the first point or the first index will give you the blue intensity, second one will give you the green intensity, and third one will give you the red intensity. So these all are representing every single pixel. So every single pixel will have the intensity of it. So probably if I want to show a white color, again, I'll say FF, that's 255, that's better. 255, let's say 255, and this is a 255. So if I want to show a black color, then I'll say 000. So this is how those pixels will store the information. Those pixels will be visualized in OpenCV. So OpenCV has a little bit different way to read the values, not to store the values, read the values. Anyway, so that's how it is. Let's start with the simple example and we'll see how to read this image and how to read the binary data of it. Okay, so let's see this now practically. Instead of just looking at it theoretically, it's better I can just go back and start doing it practically. So let us see how it can be done. Now to do this, I need some images. Do I have some images? Just give me a sec. I think it's already open here somewhere. I will find that definitely. We already had one seminar on that, so probably I can find it here. Workshop, OpenCV, here it is. And I have ton of images. So maybe we can use a couple of them. I love this one. Let's use this one. It is a vibrant color. It's having many colors into it. So probably I can use this one and we'll show you a couple of demos in it. I'm going to share that right here on your chat. Just give me a sec. Right here. So this is the image I'm going to use. How do you install it, Utpal? Use OpenCV for whatever. Maybe I'll say OpenCV, and for Python on Linux or Windows, they are having different instructions there. You can just go back there and say OpenCV-Python, OpenCV-Python. That's it. Okay. So just go back, use this, rather literally copy this command, go back and install it. Hopefully that will get installed here. Anyways, so I'm assuming that it is already installed on your machine, and if it is, let us start writing a couple of different examples to see some basic information of it. Okay, so let's see how it can be done. Okay, so just give me a sec. So let us see this and say how it can be done. So probably I'm going to open the OpenCV here. Now, when you say OpenCV, now the OpenCV is a little bit different. I mean, it's a little bit different to OpenCV here. It's not the OpenCV. You will not find the name as OpenCV. It's called as a CV2. So that's the name of that framework. That's the name of that package. When you install that OpenCV, it is going to get recognized as a CV2. CV2 is the way we are going to import OpenCV into it. That's the first one. Now let us start with a very simple example of it. Let's say this is my function one, as simple as that. Now, what I want to do here is I want to load this image, the image which I just shared with you. That's Messi 5. What I'm going to do here is I'll literally put that right here, and then we'll start loading it inside our page. Let's see how it can be done. Just copy that in your current directory and then start writing the code along with me. So what do you want to do here? The first one is like I want to open the file. How do I open the file? Open the image file, of course. How do I open the image file? I'll say cv2.imread. imread is the one which is going to read an image file from your disk path. So probably it's there in my current directory. I can say /messi5.jpg, and this is the one which is going to read an img. img is nothing but my image. Now, before I do anything, I just want to put this image into my console just to see what is getting read inside that img variable. So let me call that function one here and let us see what is there. So probably if you look at this one, this is a Messi 5 image. And when I say this is the Messi 5 image, this is the image I'm reading right now. See, this is the image. But can you see that it's not getting read as an image, rather it is getting read as a three-dimensional array. So you see, this is a three-dimensional array here. This is my pixels information here. This is my 0th pixel, 00 pixel, 01 pixel, so on and so forth. In this case, this is the B, this is the G, and this is the R. So BGR is representing one single pixel. So 39, 43, 44. Maybe if I just go back and use a application which is on my machine right now, because I'm a web developer as well. So I can use these numbers, let's say 39, 43, I'm sorry, this is the B channel. So B is somewhere here. This is 39, 40, 43, and 44. So this is the color that is getting generated on the 0th pixel. And I'm sure about it because you can see that right here, this part, this is the 0th pixel. That 0th pixel is having this color. I hope you can understand what I'm talking about. So probably this color is right there, which can be represented by BGR, something like this. You know, maybe I can use maybe one color here. Let's see what this color is representing. 57, 55, 55. So this is 55, 55, and 57. What color is this? Maybe still it is a kind of black color. Maybe I can use something else. Let's say 46, 50, 46, 50, 46, 50, and 55. Still it is a black. Maybe we are talking about only this particular portion. That's the reason why we are not getting any other color than this. Not a big deal. When we run our application, probably we definitely will get the other colors as well. But you can understand that these numbers are representing the color intensities of B, G, and R. So blue channel, green channel, and red channel. Anyways, I want to show some different information about that image. The very first thing which I want to see here is what is the data type of it. And you'll be surprised to see what exactly the data type of that image is. So probably type of IMG, which is equals to, use the same type of IMG, and probably you will wonder what exactly it is. Don't wonder, because you already know this. The type of IMG is, oh, look at that. It's NumPy ND array. Oh, does that look familiar? I hope you might have seen that earlier, right? So basically this is nothing but NumPy array. As I mentioned, this is a kind of 3D array, and this 3D array is getting read internally as a NumPy array. So this is nothing but a NumPy array in OpenCV. That's the reason why we already have seen NumPy before. We already have seen NumPy little bit in depth, because I know that NumPy is used in various different packages. Pandas, this is another package where it is directly used. If there is no NumPy, you can't even read an image there. So let's say we already have read an image here. Let's see what is the different, what are the different types of properties, or what are the different properties of that IMG file, IMG variable here is. Maybe I want to see the shape of IMG. You know, this is a NumPy array, right? So I can say IMG dot shape, and this will tell me what is the current shape. I don't want to print this anymore because we already have seen that. So let us see only the shape. Can you see that? The shape is 340 by 548 by 3. Now, what do you mean by this? This means there are three channels R, G, and B, precisely B, G, and R, three channels. This is a kind of height, this is a kind of a width, and this is a kind of number of channels you are having. If I open this file here, and if I go to my application called as a preview, and if I look at the adjust size, I'll see exactly same thing. Do you see that? Width is 548, which you see right here, 548, that's a width. 342, that's a height, and 342, that's a height. So there are, let's do the calculation very quickly, and you can understand how the images are getting stored behind the scenes. Sorry. Calculator. Yes. So if I say there are 342 pixels along the vertical axis into 548 along the on the horizontal axis into 3. So these many pixels are there into this image. Almost like 562,248 pixels are there inside this particular image. I mean, though it looks very simple to you, for a human eye, but look at the way the images are getting shown and how much CPU is getting used here to display even a simple image like this. That's a very small image. Maybe think about the video. When we're talking about a high definition video, a video is made up of different images. So those images, they are getting shown in a very fast manner, so we feel like we are using a video there, or we are watching a video. Actually speaking, these are not the videos are made up of different images there. So this is a very simple image which is having pixels of almost like how many sorry, this is not a pixel is 548 into 342, whatever. These many pixels, 187 by 416 pixels are there. So maybe if I just go and say into 3, then we are having these many channels. Into 8, these many bits divided by 8 will give me the bytes, divided by 1024 give me the kilobytes. So almost like 549 kilobytes is the size around. So if I just go back here, because that's a JPG, it's kind of compressed. That's the reason why you see the size is almost like 75. This is JPG. I don't know whether you know this or not, but JPG is one of the joint photographic image. Joint photographic image is one of the compressed image file format. That's the reason the entire information is compressed into only 75 KB. Actually speaking, if I just want to go for the raw image, this will be a kind of 549 kilobytes. Whatever it is, the more important part for me is like the shape is telling me what is the height, what is the width, and what are the number of channels present here. I can separate this information. I hope you remember, we already have seen this example earlier as well. Maybe I can say height, width, and channels equals to img dot shape. Shape is representing shape is returning a tuple. A tuple is having 3 values, and those 3 values can be separated by using height, width, and channels, which can be used later to display some more details about it. So what is the height of it? Maybe now I can display the height, or maybe I can say resolution of that image, which can be something like width by height. So this is width by height. That's the way we can represent the information. So what's the resolution? 548 by 342. Generally, when we talk about resolution, we talk about width and height. So that's how we can represent or we can get the information about that image. So we can get the resolution, we can get the number of channels, we can get many different things out of this one. So hopefully you now know that how to read a file. But just to read a file doesn't make any sense. I want to display that file as well. I want to display that image as well. How do I do that? To do this, we are going to use a cv2.imshow is the function. So I'm going to say imshow. Im stands for image. Show is nothing but show that image. I want to show an image. Which image? img. The image will be shown in a window. So image will be shown in a window, and window requires a title. So here is the first parameter where I can say this is a messy image. Messy is going to be the title for that window where the image is going to get displayed. Watch this. I'm going to run this code, and when I run this code, I don't know whether you noticed it or not, but it came and it went. You see, for a couple of seconds it came, it kind of getting shown there for a couple of seconds, and it automatically went up. What happened? I mean, it doesn't wait for you to see that image. It just shows their image. I mean, it shows that image and it automatically goes away. If I want that image to be there till I escape or till I want to close it, I can use something called as wait key. Wait key 0 means unless user presses a key, I want that image to be there on my screen. This is called as a wait key 0. Wait key 0 is the way we want that image to be there on the screen till user presses a key. So I'll say show the image and wait till user presses any key. So if you press a key, it will go away. Let's see this now. If I open this image, if I run this application, see the image is getting shown and it will be there till I press any of the keys. If I press any keyboard key, it will automatically go away. Now, when it is going away, it's very important because we said that show the image in a window. So it is very important for us to destroy the window as well, because if you do not destroy the window unnecessary, it is going to accumulate some memory, which can be released only by saying destroy all windows. So maybe I'll say destroy window by saying CV2 destroy all windows. So this was going to clean all the memory used by this image internally. So okay. So probably now I want to just show you something. Are you guys paying attention now? Because this is something which I just mentioned last time theoretically. I want to show that practically now. Are you guys paying attention on the screen now? See what I'm trying to show you here. You can do it on your machine as well. Just use your scroll view and try to scroll, try to zoom into this image, zoom into this image, zoom into this image. You see the pixels are getting shown separately. Pixels are getting shown separately, and in a second you will see every pixel's intensity. Oh, all of a sudden I started getting the numbers here. Every pixel is having 3 numbers. You see, maybe if I want to see that red color or this ball yellow color, you see this is a yellow color. How the yellow color is getting shown? It's 337 by 248 by 68, whatever it is, you know. So if I just go back here, this particular pixel is having these 3 color intensities, and I can directly do that with my application which I was using earlier, just to verify whether it's right or wrong. So probably I can just go back. It's RGB or BGR, whatever you can say. Let's do this here. It's R237. Green is 247 and blue is a 63. So if I look at that, the color exactly matches here. That means every pixel is storing the intensity of R, G, and B. You see that this is a black color or maybe a blackish shade. It is having its own intensity. This is a bluish shade. It is having its own intensity. So probably now you can understand, now you can see the big picture. For us, it is an image, but for computer, this is a pixel, and this pixel is having three intensities: red intensity, green intensity, and the blue intensity. And based on the intensity level, it illuminates or it glows that LED. And that LED tries to show you different small color, multiple colors coming together generates an image. And this image gets refreshed every single second. So per second, it is going to refresh that monitor, it is going to refresh that image. That's how the images are getting shown on the screen. That's how the images are also getting shown on your televisions as well. Guys, do you see what exactly you are getting here? I don't know how appreciate you, how will you appreciate the OpenCV's effort here, but if I were you, I would see that what exactly the image is representing now. I mean, till now, you must be wondering, like, images are there, it's a Messi, or maybe it's Aishwarya Rai, or maybe someone else there. But behind the scene for a computer, it's nothing. For computer, every single image is a kind of only pixel with only three boring values. You know, for computer, every single image is made up of small pixels, and every pixel is having three values. This is just the beginning of it. For many people, this is a career, and believe me, this is worth it. This is worth it. I mean, when you talk about the image fundamentals, there are many different things here. I mean, I'm not even going in details of it, but just to be again scratching the surface, this is what you can get here from any image. And doesn't matter which image you are looking at, every image is going to tell you the same thing. Every pixel is having three values, and those three values are getting used behind your monitor to glow that particular LED there. How is the intensity decided and assigned with the RGB number? The one, for example, when I create an image like this, for example, when I say I want to create an image, let's say my image dimensions are 10 by 10. So this is the very small image. You see what I'm going to do here. See, I'm going to zoom it a little bit so it will be easy for me to go back and modify this. I can't do it other than that. It's okay. So if I just put a pixel, that means I put a pixel here. This pixel is kind of getting a color information of 0, 0, 0, and rest of them will have let's say FF, or 255 or 255 or 255. Watch this. I'm going to store this image into the same directory which I am using right now. So it's there in my somewhere in today in Python, and I'll say that this is the test image. You know, let's open this test image very quickly and see what do we get there. So probably I'm done with this. I'm going to go back here. We'll write a very simple function, so you'll understand what exactly is going on and who is creating those images, intensities, and other things. So again, it's kind of img, which is equals to cv2.imread. Where is it? It's .test.png. And then I'm going to show that image by saying cv2.imshow. I'll say this is a test image, and this is the img. Once you're done, you can say wait for key. That's 0. Sorry, wait for key 0 means just wait for user till user presses a key, and then destroy all the windows, and then you can call that function right here. That's it, function 2 rather. Let me run this code, and probably if you run this code, probably you can see that this is exactly same image I'm looking at. So probably if I just try to zoom in, you see all of these are having 0, 0, 0 values. But if I just look at this particular position, you see all of them are having values 255, 255, 255. So as and when you create an image, who's that? Snehal. As and when you created that image, you might have added the colors there, and those colors are getting stored behind the scene. For you, it's an image, but for machine, it's just storing that information about the pixel, because every image is getting stored as number of pixels. And for every image, it is going to store RGB information, nothing more than that. Okay, what's that, Vipin? Are we able to do the vice versa, like using an array image, you can get image? Of course, yes. I mean, there are many different demos, but those are reserved for the other one. So probably, yes, you can easily. Okay, you can. Vice versa is also true. And there you can create an array of different values, and then you can construct an image out of it. Very much possible. Yes, such amazing works and making it surely wonderful. It is wonderful. I mean, I love OpenCV just because of the reason that it made the image understanding very easily. I mean, till the time when I was reading the OpenCV OpenCV package or OpenCV's documentation, I was not knowing what image means. But when I saw that OpenCV for the first time, and when I saw that with my own eyes, then I understood, images are getting stored like this. Because unless you understand this, we simply say that every image is having some characters, every image is having some different information about it. But for a machine, it's same. It's really same. Maybe it's our own eyes and brain works makes sense. Exactly what you said, Snehal. It's just the human brain. I don't want to give that example, but still, this is a kind of a hottest topic these days. But you see that God has made all the human beings same. For God, every human being is a human being. Every human being has the same number of parts of bodies. But when we, as a human, think from our brain side, then we start differentiating Hindu, Muslim, Sikh, Isai, and other things. But behind the scene, all of us are human beings. This is exactly what happens here with the image. For computer, every single thing is a pixel. We as human try to differentiate. Oh, this is a Messi's image. Okay, maybe that is something else. Maybe if I look at this one, this is Messi. If I look at this one, this is a robot. This is my head. This is my brain who is understanding that image. But for machine, it's very simple. It's just pixel, pixel, and pixel. Nothing more than that. Okay. Yes, it is true. True. How do we read the letters and numbers? Same, exactly same. The only difference here is now if you try to read the pattern and the pattern is giving you, like if there are, let me just go back here. I'm not going to do much of data of it right now because that's a machine learning image recognition part. But if you are curious about it, let me just show you an example of it. Just imagine that there are a few pixels. There is a pixel here. And there are a few pixels which are kind of arranged in this fashion. Maybe this is the pixel here, this is the pixel here, this is the pixel here, this is the pixel here. And as the pixels are getting read, you see that if the OpenCV finds out a pattern, like this is a kind of a pattern it is finding out, then it will say that, hey, it seems like it is a letter A. So it will try to understand the pattern of different pixels, and then it will try to recognize the letters. It will try to recognize an image. It will try to recognize the features. So probably Nidhi, you're talking about the letters and numbers. That's how the numbers on letters are getting recognized by OpenCV. See, what number is it? Probably if anyone looking at this one, this image can understand, okay, this is a number 1. I mean, it looks like a number 1. So there are different pixels and giving a pattern of number 1. So looking at the pattern of pixels, OpenCV will try to understand, oh, this is number 1, this is letter A, this is letter C, it is letter Z. Of course, it has to recognize this letter with the help of machine learning. It has to learn that this is a, this is a B, this is not character Z. How does it do that? It does that with the help of ML. And that's the reason image processing is the first step of machine learning, precisely deep learning, precisely image recognition. You know, yes, it will work with the typed data as well. Of course it will. Like Google handwriting, exactly. Google handwriting and all of these things are doing the same thing behind the scene. Can we add some data on an image? Of course you can. You can. See, ultimately this is in your hands now. You decide what you want to add there. So every single time when we are talking about a kind of an image, every image is made up of pixels, and what you want to add in the pixel is nothing but your data. You decide what data you want to put there. This is a very simple example. Let me show you a couple of more examples of it. Maybe I'm going to copy this code right now, or maybe copy this code, and let's go to the next function here. So this is the function 3. Let me show you a couple of different examples now. This is my function 3, where I'm going to read the file again, Messi, because it has some valid information. And this is a Messi's image. Let me call that function 3 and run this code. And probably, okay, it's shown somewhere. Let's close this and then run again. So if I run this code again, this is the Messi image, you know. So this Messi image is reading all the 3 channels in it, you know. So when I'm reading the file, I can come back here and I can say CV2 dot, CV2 dot, I want to read the only the green channel out of it, for example. So I'm saying, so not green, gray channel out of it. So I can say, I am read underscore, maybe I just want to go for a grayscale image. Grayscale image means out of 3 channels. I hope last time I mentioned every single pixel is going to be represented by only one, a combination of 3 colors, R, G, and B. But here, what I'm trying to say is don't read all of these three values. Just read only the color intensity of a black. So basically what I'm trying to say here is read the image as grayscale image. See what happens now, grayscale image. So while reading this information, we are not reading all the channels. We are just reading only the black intensity, and probably you can see that all the colors now are gone and they are kind of represented by the black intensity. So basically this is a black and white image, and you know that in black and white image you are going to have only one color, that's black. That's it. So what is a percentage of black color will be represented at that particular pixel will constitute different pixels together to create that image. So this is a black and white image, and see how simple is that. You're just skipping the three channels and just reading only one channel out of it. If you really want to see that information, you can see that right here. See this. Maybe I'm going to do the same thing again what I did last time. Get the width, height, where are you? Width, height, and channel information here, and let us see what does it show. You will see that sorry, there is a channel. Okay, so here we are not having the third part here. Maybe we don't need this right now. We can just look at this one, because here you will see there is no channel. I mean, there is no channel information because it is having only one single value. Last time, if you can compare it, it was showing me three values. One was the height, the second one was the width, and third one was the number of channels. Now we are reading only one channel. This one channel is nothing but your black intensity. So you can see how simple is that to read an image into a grayscale just by skipping those three channels and just by reading only one channel there. That's it. That's it. Very simple. But sometimes it is required to read the entire image as a colorful image, and I want to convert this image into black and white. So I don't want to read this as a black and white because I will lose the color information. So what I'm going to do here is I will say this is my original image, the one which is in color. See, this is the original color image, but while while displaying it, I want to convert that into grayscale. So I'm going to say img underscore grayscale. This can be done by saying cv2 .cvt color. This is an img, and I want to convert that into cv2 dot color bgr to gray. In a sense, the color information is stored in bgr, and now I want to convert this to the grayscale. See what happens. This is my original image, Messi, and I'll say Messi dash grayscale. Make sure that every window is having a separate title or a unique title. Otherwise, the image or the window will just get overlapped. So when I say run, probably you will see both the images. This is my original image, and this is my grayscale image. See how simple is that? So probably what you see here is like you are trying to get the information and just converting that information into a black intensity. So ultimately, this is storing three values per pixel. This image or this representation is storing only one value per pixel. The one value here is nothing but the color intensity of black. Three values here are nothing but the three different channels, R, G, and B. So that's how the color image is getting shown, and that's how the black and white image is getting shown. So ultimately, both of them are having pixels. Ultimately, both of them are storing the pixel information. The only difference is here we are storing only one channel, and here we are storing the three channels. So now you can understand how we can convert our a colorful image into black and white. Can we increase the DPI of image? No, you can't. That is already decided at the time of creating it. You can't do anything on your own while reading the information. Okay. Girish, you're saying, can you show an example of adding a data at a specific location on an image? Of course, yes. I want to show you that example because you know what? That's a very interesting example. And I can bet on that. When you see this example, you will be blown away with the power, how powerful that OpenCV is. Let me just go back here and say this is page 3. And right here, we'll start again, import CV2. I'm having too many things here right now, but let's see how many of them I can show you. So probably this is my original image. Watch what I'm trying to show you. Guys, I hope you are paying attention because this is a nice and very powerful demo of OpenCV. See, generally what happens here is when we are trying to, how can we import OpenCV? This is the one, import OpenCV. OpenCV, that CV2 is nothing but the OpenCV's package name, okay? Yes, Snehal, look at this one. So probably this is an image, and if you pay attention to this image, what I'm going to do now is this. Probably I'll just try to, okay. So what I'm going to do here is I'm going to replace some, I'm going to extract some information out of it. Now, let's say if you are using, so if you are using, let's say, application like Preview in Mac, for example, I can literally select this particular part and then I can say Control C, and then I can come back and create a new image out of it. So probably new from clipboard, and I can get one image here. If you're using Photoshop, this can be done easily. If you're using Photoshop-like tools, this can be done easily. But now if you are using OpenCV, programmatically, you can also do it. See this. If I want to extract this feature here, this is the ball somewhere, and I want to extract this feature here. How do I do that? See where the ball starts. Maybe it seems like the ball starts. Look at the X and Y here. So somewhere here, ball starts at XY 332. Maybe we are going to consider it's 330. Y is 287. Let me mention it somewhere. So let me extract this ball feature out of it, and then we can override this feature somewhere else. Check this out. Probably I can say the X and Y, or X1, Y1. So what is X1, Y1? X1 is 330, we saw that, and it was 287. Let's make it 290, just a round figure. And hopefully this is the top corner. So probably this is the top corner we are talking about, this one here. Let us look at the bottom corner as well, somewhere here. So probably somewhere here it finishes. It's almost like 395 or 390. Let's consider this 390 x-axis, and y-axis is 335. Okay, 391, 335. So let's say x1 391 and y1 it's 335. So how do I extract the feature out of it? I mean, by literally knowing the X and Y position of it. How do I get this? Image is not zooming on my windows. Are you using your mouse? Because unless you use mouse, you can't do it using keyboard. So probably use the mouse and probably it will be done. Are you using that? It's not giving you? No, not at all. Windows, you are using touchpad, that's okay. Touchpad will also work. Unfortunately, I don't use Windows, so not getting on Windows. So okay, then you are so unlucky people, because Windows is not supporting in that case. Can't help. This is something which is not available on Windows. So sorry for that. Okay. Anyways, so what I'm trying to say here is, now you can pay attention here. If it is not on your machine, you can at least pay attention to this one. You can get it this one. So what I'm going to say here is, I'm going to extract a ball image out of it. How do I do that? I know X1, I know Y1, I know X2, and I know Y2. So I know this is an image. Image is nothing but an array, and array is having, let's say, array is having the positions, right? Do you mean the Mac only support will raise the concern Windows? I don't know. Maybe when I don't use Windows at all. So I mean, for at least for this purpose. So I don't know whether it supports or not. But if it is the case, then we can raise an issue to those people and saying, hey, Windows, it's not showing up the information. Whatever. Generally, Sripati, when you are in this business, designing business, most of the times people use Mac. They don't use Windows, or they don't use Linux. They generally use Mac. Okay, so maybe Mac is having some more information here buried behind the scene. That's a reason, probably. Whatever. So let's look at this one and see how we can do it here. So probably, if I want to get an image or a portion of an image, this is how we can do the job. Here we can say y1, y2, and say x1, x2. So if you know the coordinates, you can extract the portion of it. What is y1? It's 290. What is y2? It's 335. I hope you can understand what do you mean by this. This is our colon. This is our range, range operation. So I want to get this from, let's say, from the point 295 to 235. 290 to 235. And from x-axis, it's 330 to 391. What we get here is nothing but the ball. And if you don't believe me, let me just go back here and show that ball right here next to that image, next to that Messi's image. I'll say ball, and this is the ball. If I run this, probably you can see, look, this is my original image, and I got this feature, I got this ball extracted out of it. Not extracted in the sense, not cut pasted it, but kind of copy pasted it. See, if you are using at Photoshop, you can do it by using, by using simply a kind of mouse or this thing. Here, I can do it without using a mouse just by looking at the XN file. Now today, I try to get these values by moving the cursor on top of that image. If you know machine learning, you can do that automatically. Of course, you don't even have to go for entire machine learning. OpenCV alone can do it with the help of something called as a contour. So OpenCV does support something called as a contour, and in that contour, you can easily do it. Let's look at an example here. Let's see what is the calculation saying that. Maybe this is 290 to 35 means 90 plus 10, 30, 35. It's almost like 45 pixels here difference. And let's say 330 to 395. Let's use 390. So it will be 70% difference. Now let's see, this is the way we are extracting. So extract a feature or extract a part of image. Extract a part of image. Now, whatever you have extracted, you can also go back and try to put that on different location as well. So probably you can do it in the reverse way. Someone was asking, can we gather the information on our own and create an image out of it? I said, yes, it is possible. See this. Maybe let me open this image first and see where we can put the image. I'm sorry. Okay, so I want to put that ball somewhere here. Okay, somewhere here means somewhere here. Let's start with 50. 50 to 99 is where I want to put this ball again. So if I want to go back here, say 50 is my starting position. So 50 is X. So what is the difference we are talking about? We are talking about a difference of 70, because you see 330 plus, I'm sorry, not 70, it's 60. So this is the difference. So 390 minus 330 is 60. So 50, and the next part is 110. Or the next X pixel is something like 110. So 290 is what I said last time. This is the Y part. And if I look at the Y's difference, it's 45. So maybe plus 45 is going to give me almost like 335 only. So that's a Y position. So basically what I'm talking about is nothing but, let's say 50 to 90. That's nothing but the first X coordinate on the top left corner. And this is 110. And 335, that's the last coordinate, or maybe the right bottom coordinate, something like this. So what I'm doing here is like, I'm trying to say, I can extract this feature and I have to use the exact same number of pixels there, and I can put that in my image back on this particular position. This is my X1, X2. This is my Y1, Y2. The way we have to write it like this, 290 by 335, comma, 50 to 110, which is equals to ball image. I don't know whether you are getting it or not, but basically what we are doing here is we are literally getting the ball information or ball pixel intensity from this position, and we are kind of pasting it into the another region. Let's see what happened. Oh, did you see that? Magically, the original message image was having only one ball. Now magically, I added one more ball here, which means these pixels I manipulated with the pixel intensities of that ball, which I saw in this particular portion. So this is the ball image. It was there. I just tried to programmatically put it right here. Guys, did you understand what has just happened? I tried to extract the part of the image by using X1, Y1, and I tried to put that in a different portion of it. So this is just the simplest demo out of it, literally. And that's what I generally say in OpenCV's demos. Like, if you know OpenCV very well, who needs Photoshop? Photoshop is a licensed copy. You know, you don't have to pay a single penny to anyone if you know how to use OpenCV, and you can do every single thing programmatically. This is just the beginning. I mean, there are many different things out there, but because of the time limitation and just introduction level, I'm kind of, you know, restricting myself here. But otherwise, there are so many things. Anyways, yes, there is no model in CV2. Probably, Utkarsh, you haven't installed OpenCV properly. That's the reason why it is not working for you. This is an error. OpenCV is not installed for you. OpenCV, get it installed, and then probably you'll be able to see it. Okay. Anyways, so probably this is a very, very simple example of it, and probably it must have given you an idea about how we can start doing all of this kind of job. Maybe any certification for OpenCV? No, OpenCV does not have any certification. but we generally conduct a seminar on that OpenCV. And if you are interested, I've given one simple demo on my YouTube channel. Just search for there and you will see I've given an example of how cam scanner works behind the scene. Nitip, you are saying this now, this Windows is crap. I realized that a decade before. That's the reason I've left that particular word. You know. Okay. But thanks, you realize it. Anyways, Girish, so text instead of image, you can do anything there. You can draw any image, you can draw any text on it, and you can do anything there. Yeah. Anyway, so probably I'll give you that URL later. Just look at that demo. That demo will give you a perspective transformation. The demo which I'm talking about is giving you a perspective transformation. I'll share that link there on your WhatsApp group later after the session today. So you will get to know how powerful OpenCV is. And if you know OpenCV, what can you do with this? Okay, I'll give you that URL. You can take a look at it. Okay, Shripati, I'm so sorry for that. I'll give you by today. I forgot that yesterday. Okay. No problem. I'll give you that today for sure. Anyways, I think it's better we can call it a day right now. This is just an introduction to OpenCV. If you want to just learn further or if you want to do something more on it, probably you can look at the documentation, or maybe we'll let you know when we are having OpenCV demo or OpenCV seminar. So if you are interested, you can come there, join us, and then we can see some advanced part of OpenCV where we can see all of this stuff, how to extract an image, how to do the magical stuff behind the scene, what Photoshop is doing for you by charging you thousands of dollars. So basically that's not required at all. Anyways, yes, I'll share that. Okay. By the way, today is not the last day. Tomorrow is something we are already having one more session attached, one more session extended. So please don't forget that tomorrow, though it's a Saturday, we still are having a session. We'll have the same timing, 10 to maybe 10, sorry, not 10 to 8 to 10 or 8 to 10:30 max to max. Okay. But hopefully tomorrow we are going to see the remaining 4 topics. Okay. And I'll try to include one more. Someone is saying that I forgot that. Thanks for reminding me, by the way. So let me come back here and add one more, regex. Those people who know what regular expression is, for them, I'll include one more topic, regex. Okay, not a problem. Fine. Okay, so I think it's better we can call it a day right now. We are new session for Flask. No, not at all. Not right now, at least. If there is something, I'll let you know. Okay. For generator. Senthil, I think we'll see. In fact, if you are really interested, we'll try to see a small demo of it. Yes, tomorrow. Generator. There are many different things, you know. There are many different things. Anyways, let's call it a day. If you are having any question regarding the different courses, you can put that part on. You can put that question on your WhatsApp group. We'll discuss it there, right? I know many people are here. Those who are going for different companies, so I don't want you to. Yeah, I don't want you to get late. So better we can call it a day today. We'll talk about the remaining topics tomorrow, and probably tomorrow will be the last day. Okay. So please don't forget, tomorrow you are going to have a session at exactly same time, 8 o'clock. Okay. Okay. Again, thank you very much for attending today's session as usual. And I'll see you tomorrow exactly at 8 o'clock. By the time, have a very good day ahead. Okay. Bye-bye.